The other day, I had a project idea that I wanted to build. So I do Mule work, and I'm not going to talk too much about Mule, but Mule is it's an integration framework tool, and what you write in is XML, but the XML is a domain-specific language. And so XML sounds bad, but you have if statements in XML, you have or for loops in XML. Well, I wanted to be able to kind of static type check some of the XMLs. So case in point is when you go to a database, I feel like I'm really loud here. When you go to a database, you make a database call or you make an HTTP request out, a lot of people want to track when that request went out, possibly what was data that went out, and then when you got the response back. So that way, later on, more on the operations side, we can have timings around how much of our requests are taking. But as you're developing this code, some developers don't put those statements around those requests, and so they don't take, you lose that information, right? You can't go back and do some analytics around that. So that was the start of me creating a project. I wanted to make sure that anytime there's a database call, that we have those statements before it and after it. And there was lots of other things that came along with that I won't get into. But anyways, so I started getting into domain-specific languages, and I knew I didn't want to create something where I had to parse it, right? I didn't want to figure out how to do Lex or anything else. I wanted to be able to just kind of get past it and go on. So I knew that Groovy had a way of doing DSLs. I've seen some of them used before. Some of them are more function API calls like we're used to, where it's more of a fluent interface, where it's just a bunch of dot notations. But I've seen some things with Groovy where it was DSL-like, but it still had a Groovy syntax to it. And I thought that was sufficient for what I was doing. There's still a lot of code in Mule that's Groovy. So I thought that would be a good thing to do. Plus, my users weren't business analysts, weren't subject matter experts. They were other developers. So I really felt like creating a DSL that my audience was the right audience to target. Right? If I was dealing with other people that aren't programmers, I would probably find a different way of doing this. So that was the beginning of this trek. I'm still kind of figuring stuff out. So I got a couple slides where it's like, I really don't know about these subjects right yet. I'm still working on it. So you can take this in many different aspects. The Martin Fowler's Domain-Specific Languages book, I'm reading that. And in that book, that's more around you really tailoring and creating this language from the get-go. How to parse it out, how to model it, state machines, etc. I don't have a lot of those worries and concerns. I'm not really dealing with a state machine for what I'm creating. But this is definitely something that I think can grow and get very large and get big. But I'm not going to get too far down deep into that. I'm going to kind of keep things really, really, really simple, mainly because I get simple stuff. So that's basically all the slides. I got a couple slides later on that I can show, but I'm going to drop down into code. And excuse me, I meant to get this set up at the beginning, but I didn't do it. That's font. So there's a couple ways that you can do some of this font. I'm going to do a restart. IntelliJ has a presentation mode where you can blow it up and it looks really nice and everything, but I've not used it before, and I don't know if you can see the console output in it. I think it just shows your editor. So I'm going to try that just real fast. So I'm assuming you all can see that. And it's kind of small, isn't it? So there is, let me figure it out. So you can enter presentation mode, but I don't think it's going to show the console. All right. Okay, so this is just a real simple Groovy. Basically, everything is happening in Groovy shell. That's where the whole DSL takes place. So it's just a normal script. And I am going to have to take out of this because I'm going to be swapping back and forth. So I'll up the font some more. Okay, so we've got just a normal, simple script that you would expect. I say what you would expect, which looks like normal code, right? We got the parens, we got the semicolons, etc. I meant to have in here. Okay, there we go. So we got the import statements. This is the normal, basically a Java Groovy file. And one thing Groovy does, if you don't know, if you haven't had much experience with Groovy, is it takes your code and wraps a class called script around it and provides you with a static main method already. So everything from line 5 down is basically put in a static main method for you. So we just got a normal Java class. So that's what the runner does, and it executes in the car. So let me go back here. So we're doing up a car. Tell it to start, tell it to drive, tell it to turn, right? It doesn't look like much of a DSL, it looks like normal code. We'll get there. So for the car, I got my class up here. It's just a normal car class. So SLF4J is an abstract key transform. It's an AST transform. AST extension, excuse me, that was redundant. An AST extension where it injects a log for you automatically. So that's why I can do, I don't know how to point here. That's why I can do log within the class. That's where it comes from, the SLF4J. So anyways, I just do some logs, and as you can tell down here, we're actually calling those methods. We're going into the start method, we're driving those 3 miles, and we're turning left. Okay? So that's great. So what's kind of some things we can do to start moving this along a little bit more? Well, the first thing we can do is we can pass into the Groovy shell. We can tell it, we can pass in a configuration, and in this configuration we can add a lot of different things to it. One of the things we can add is we can add imports. So we basically have already imported, the auto car, auto direction, and scripts distance for that script. So we don't have to have that in our DSL anymore. So in this DSL, this will still run. We can execute this. It'll run as expected, or it should, demo demons, right? But we can also take those out and run it again, and it works. So one less thing to worry about. We've taken out some of those import statements. Okay, so the next thing, what can we do? One thing is we're doing this new car, right? We don't want to new up something. A lot of times you want to pass in a variable, you want to pass in a customer, perform these rules over this object. So we need to pass in that car. So we can do that, and you create a binding. And a binding is just a map, right? Key value pair. So we have car, and we just new it up. With this binding, we pass that into our Groovy shell with the binding parameter. So if we go back to our DSL, so instead of new car, we can just reference car. So again, we'll run this. And it's going to run this DSL. We're good. So just to let you know, just FYI, I'm not pulling your leg. It is running DSL03 text, right? So we can take out this car statement, and we can run this again. And we're good. Right? And the applause. Ah. Do what? It's getting smaller. Okay, so I can only go to 9 and then talk's over, then we're done. So enjoy the pizza. Okay, so that was taking that out. 4, so it's Groovy. If you don't know much about Groovy, a lot of things are optional. You don't have to specify them. So we can take out the semicolons. If you have a method call with an argument, you know, parens are optional on that. So we can take off some of these parentheses. Now we can't take those off because that's there's not an argument, not a single argument. There's no arguments on that method call. And if we take that off, then Groovy interprets start as a property. So it's looking for a property, it's looking for get start instead of a start method call. So we can't take that off yet. And then this is a constructor call, and we put that on there. Okay, so we can have it like this. So we can run number 4. And we're still good. Yes, question, first question.
So if you put the parentheses back around after drive, can you take them out of the new distance?
I have not tried that. We're about to try it. I don't think so.
Yeah, I think this is going to treat miles as its own argument.
Yeah. Ah, it worked.
That's ambiguous.
Yeah. So we can change this to 4, and you see down here, 3 miles. Run that again. Uh-oh. Uh-oh. Oh, stop. Whoops. Whoops. There you go. I was moving stuff around, and I thought I had it all taken care of. Okay, so we need that back in there. Back to 4 miles. Make sure we get. So cool. Awesome. Okay, so continuing on. So we're still doing a direction. So if you look, we're still just doing this direction left. So again, we have these imports. Now we can do a static import. So this is the import static dot direction star, right? So this does the star, so you note the word there, which is kind of the key part of this. So we can run 5. Let's make sure that we're actually executing 5. And we're good. So I can now take off direction. And we're still good. Okay, so one thing on direction is that's an enum. So as you start creating a DSL, what do you want your DSL to look like? Do you like the capital L or do you want a lowercase l? Right? So that becomes a conscious thing. When you start developing in code, everybody has this, their own opinion on how enums should look, whether it's all capital letters or just a single capital letter, et cetera. So you have to kind of figure that out and how that DSL may not look good in code, but it may look good as far as words to another person. So as far as direction, we can take and make left lowercase, and so that will fail now because left isn't found, right? It's not known. So we can then change our DSL to a lowercase l, and we're good there. So it's depending upon, and everything it starts getting into this really subjective, up to your own will and how you want your DSL to look like. You can kind of change some things. All right, number 6. Okay, so this is where it starts getting the script-based class. We're going to bring in this script-based class. This adds the ability to really start kind of, as you would think about, really changing up and creating a DSL. So with this car script-based class, we're going to put it in there. We've defined a start method, guess I'd start doing that. That'd be good. So we've got our start method defined. We've got a turn method defined, so on and so forth. You can kind of build this up, right? These become words that are immediately available right in your DSL. So as far as running this, so we've got car.start and turning. So we're going to run this, make sure we're good. This is kind of for me too, make sure everything's, I didn't break anything. Oh, I changed left. Okay, so now our base script class is there for us, and it's available to us in our DSL. So as we've got a start method there, now we can use that. Instead of saying car.start, now we can just call start. So as down at the bottom, you notice that we are in car when we call start down here. So now in our DSL, when we take off car and we're calling that start, that's calling in our script base class. So now we can run that. And so now our calling start happens in our base class, that script base class. But all our base script class does is basically delegate to the car object. So this is what I'm using a lot of in creating my DSLs, is putting a lot of functions here that's available right off the bat and not having to tie it to an object. So you can also turn. So instead of saying car turn, now we can just say turn left. And that works. And of course, now we've also did that static alias or the static import for direction. So now we can take off that. And that works. So we're calling the function turn using the enum value of left. So now you can start kind of seeing where some of this DSL comes into play. So this is, ooh, easy. Right? This is what it is equivalent to. It's basically what's being called. That's what it gets converted into. This is a little bit low and a little bit odd to type on. Okay, any questions about that so far? All right. We're almost done, you guys, and we're done. Okay, so for 7, let me bring up 7 here. So the other thing we can do with Groovy, again, I don't know what experience anybody's had with Groovy, but you can also do dynamic programming. You can change the meta object on classes. You can add your own things. So this adds a method call. This adds a method call get miles to the number class, any number. So you can say 1.getMiles, 3.getMiles, 12.0.getMiles, so on and so forth. Well, the way Groovy does with properties, instead of making a method call getMiles parens, in Groovy you can just say .miles, and that gets translated into .getMiles. So basically with this, we can say 12.miles, right? Drive 12 miles, do this and do that. So in our DSL, this allows us to specify those type of things. Yeah, setters is a little bit different. Setters is a little bit different because you have to use equals, right? But yeah, instead of saying set, like set miles, you would just say miles equals. Yeah. So there we are, we can now drive. Now the one thing, and again, we can clean this up. We can turn, so we can say start, turn left, drive 12 miles. Now we can't do anything with that dot. We're still stuck with that dot notation. We can't say, oh yeah, we can just put a space there, right? So there are still some code fragments that kind of get left over a little bit. So it's not fantastic. Ooh, it's It's not perfect, but it's great, especially when you're kind of dealing with programmers anyways. That's your audience. So, okay, that was 7, 8. Okay, so Groovy also has command chains. So what you would think of as like a Fluent API. So with a Fluent API, we can do something like here down at the bottom, turn left at the stoplight. And you're starting to see a string definition there, right? So we can also do string. That's the same thing. So what is this? This is so turn left at the stoplight. Let me run this. I think this is where I left some code out on purpose. No such property left for class. I should probably just change it back to uppercase L, huh? Oh, dang it. Oh. That's not worth the error I was expecting, so I'm just gonna skip over that. Okay, so for this, we're making a function call, and then that returns a closure for us, and then we're calling that closure, passing in an argument. So what does that look like? So again, go back to our car class, our turn left. So our turn, just a normal function, returns a map. So our map has a key of at. The value of that is a closure. So a closure is defined by the open curly brace and the closing curly brace. That closure expects any kind of object. I haven't had a type there, so I can expect anything. We could say turn left at 1. Whatever you wanted to have, right? And all I'm doing is just logging out just what was passed in. So we can do something with that. Now this also brings up, what do you want your DSL to look like? Because the stoplight is a string. If my target audience is another developer, then they'll probably be okay with that. But needless to say, you can evolve this a little bit. You can create maybe an enum that has many different types of objects or things out there. Objects is meaning a physical object, not a class instance object. But what do you want your DSL to look like? And so is a string okay there? You may not like that string there because you can't check it really well, right? You have to do maybe a regular expression against it, so on and so forth. But that allows you to build that the way that reads up, right? Turn left at stoplight, and you can continue that on and on, right? That closure could also return, another map where you have another, operations or that you can call and do the next thing. Does that make sense? Hopefully it makes sense. So again, this looks like this. That's what it gets interpreted as. Okay. That was number 8. Number 9. So we can continue this. Let's see. Oh, this is what I was going to say, just having another one. Turn left, then we could say turn right. So our 9, we'd have like this, right? Turn left, then right. Again, if you're giving people directions to somewhere, you say that often, right? As you're giving someone directions. Okay, so no such property right. I changed the. Now here, let me go back here. I didn't change this one. We took out start. Our car is magical and is already starting and running and hovering. Okay, so there's no method then available for us. So if we go back to car, we can basically do the same thing. So we have our first option is at. Now we're going to create one that says then, right? Because you say, as you're giving directions to people, you do say, turn right at the stoplight. Or people also, a vernacular is turn left and then go X and then turn right. So how do you want that DSL to look? So now we're just going to give them two options. They can say, at or then. So we're going to say, turning this and then that. Right? So it's a closure. Our key is then. We're returning a map. We have two keys, at and then. Both those keys have a closure return. Yeah, I call it direction. Turn left. I call this, because you're always going to say turn left or right, so that's a direction. But then, so at takes an object, which we haven't defined a type on that object. And then for then, that also takes an object. Again, we haven't defined a type for that. So these can be wherever we want to, a string or an enum, etc. Do what? Yeah, we can put some things there. I just choose not to, because I'm still, like I said, I'm still trying to figure out what we want.
I mean, does it let you, because you're not defining a particular object, that lets you do duck tracking, which passes any kind of object that accepts the arguments the object should accept.
Yeah, exactly.
So that lets you,
Yep. So we go back to here. I guess let me take this off. Oh, well, I already ran it, sorry. I was just going to show the error message. Right, I did that. I forgot. Okay, so we can run that again. So there we go. We're going to turn left and then right. And then I got to be quite honest, I don't know what number 10 is about. Oh, this is just a real simple, I just want to show you. You can also inline the script. If you go out and start reading some of the DSL examples that are out there, a lot of people will just inline the script. You can inline the script. This shows another example of having that, the chaining, the method chaining there. So that's just a way of, where one closure can return a map so you can do the next thing, right? Which kind of allows you to kind of have your directions become more of a tree and kind of grow as far as I took this operation, this operand, and that took me down this kind of path. So, they show that down there where you can say, please show the square root of 100. So that reads great. Basically what it is this is a function call, right? Please show is a function call, which is just a closure, so you're calling a closure. So please show, that's a function call. The square root, so the comes from this key. So the square root comes from that's a closure. Of is a key in this map. So that just executes that action that you passed in, which is show. What is the square root? So that just basically executes those two and puts it out there. So this is just a way of kind of doing that method chaining some more. So your map, you have the option of not creating functions. You can create closures or just more and more key value maps and build up your DSL with that way as well, depending on what you want to do. All right. You can, of course, run them for tests. I say really easy. Needless to say, back to our binding, that's a variable that we can pass in to our script. Our script can execute against that object, and then we still have a reference to that object, so we can do what we want to with that. We can persist it in the object, persist it in a data store somewhere or whatever else. For this case, we can get the car, and we can perform assertions against that car. So with this, right, we can just check that the car is started. So we run this, just one test. It's going to fail because we don't have a started property or function, right? So we can go back to car, and of course we can do something that you can imagine. We can say, started. And we can say started is true. So our tests are green. So again, if you don't know Groovy, since we have a member variable there, we don't have to define a getter and setter for it. Groovy defines those for us automatically. So Groovy basically has a get started call for us. That's what this is here. It's the same thing as basically saying get started. It's the exact same code. But the other looks a lot better, in my opinion. So, tested green. So, again, on some of those command chains where I was showing, this kind of gives a good visual on how they look, what your DSL could look like, and how does that get mapped to as far as functions, dot notations, parameters, etc. So there's DSL. Again, with the dot risk, that's a call to actually get risk, which you can see down here at the bottom. So this calculate high risk, you can have something of that sort, but it gets turned into, as far as a Groovy call, it gets turned into calculate high, and then whatever that returns back to the caller, of course, you can just call get risk on that. And so this is another way that you can do named parameters. I've not gotten into too much yet. I don't like the way it looks quite right, but you can do name parameters where you can have, basically this is a map that you're passing into talk, right? So talk accepts a map, and then on this particular map, we just have one entry, 2 is the key, and then Mr. High Key is the value. Yeah.
So is the advantage of name parameters going to be that you don't care about the order of your arguments on your function call?
I think, because I say you don't care about the order, that's kind of more of a programmer mindset, right? We don't necessarily care about that, but as far as how does the DSL read, with a name parameter, we can continue to add more and more name parameters, but yeah, you don't care. You can also have name parameters and normal parameters intermixed on a single call as well. So that's another option. I don't get into because the 2:: right now I'm trying to do more of calls such as this rather than name parameters. I like the way this looks a lot better than name parameters look. Okay, so a couple of things I still don't know much about, still trying to figure it out, but just to get you aware of it in case you want to go down this path. They have a secure Ast Transformer. And that sounds great, and a lot of the properties that you can set on this look great, but it's the author of this code has even came out and said it's really poorly named. It should be grammar transformer. So this, as you can tell, you can say that the closures are allowed, whether or not you allow someone within a DSL code, right, to call a closure or to write a closure or to pass in a closure. So that's something that you can statically check against and validate. Some of the things you can't, which is where some of these other ones get bad on. So that like the import whitelist, static import, so on and so forth, that's good. The tokens whitelist is good because as you can imagine, you can static type that there's a plus there or not. When it gets down into more of the receiver classes, that's where things start to kind of fall apart a little bit. I initially thought this was great because I could whitelist what I wanted called, what would receive a function call from, but you can get around this left and right. It doesn't do any good very much. It basically doesn't work, right? So to show that, so we've got a runner here. Down here we've got the restricted environment. I've got it where we've got the classes whitelist, and let's say that we don't want someone to call system exit in a script. All right, so I'm going to run this real fast. Okay, so process finished with exit code 42, so we can tell that this executed, right? So now we're going to bring in the call to set up more of a restricted environment, a sandbox environment. All right, so we're going to run that. So method calls are not allowed on Java Lang system. So that looks like it's great because it's not in our receiver's classes whitelist down here at the bottom. So we can add that in. And we'll get the system exit code 42. So we're good. And I'll take this back out though so it fails. And when I'm getting my code ready, I'll let that run. The reason why it's bad, again, method calls not allowed. The reason why it's bad is because someone can say, okay, I know, but you can do this, and this secure AST transformer won't catch that. So before we got the, system calls are not allowed. Oh, so here's another thing for you. Since we use an equal sign, you actually have to whitelist the tokens that are used, that are allowed as well. So on our tokens whitelist, there's a lot of them here, as you can tell. And we're going to add in equals. So that shows you the tokens, disalign the tokens, and so now that code gets executed. So that the users, I say users, other programmers, will be able to work their way around this. So it's not great yet, but I didn't know you could type in that thing. Man, learn something new every day. So this isn't fantastic. There are good things to use with it. The tokens is one thing that's good. But as far as limiting what classes people can use, maybe you don't want them to go off and hit the web or something of that sort, and you say you can imagine security concerns around this. For me, I don't have that concern because the writer of this DSL is running it on their machine, so I don't have a concern right now, but I could definitely see that as you offer this DSL up for others, and then you accept their code and now you executed it. So depending upon your use case, it could have some problems. Last thing, just real fast, the other thing I'm trying to figure out for me, I still haven't figured it out yet, is how can I version my DSLs? How can I put some kind of an identifier to say, hey, this is the 0.1 version, 0.2, et cetera, as I continue to grow and mature the DSL, deprecate different attributes, deprecate different functions. How can I do that? And I'm still trying to figure that out. So far, you can do that with the binding. With the binding, you can. Here's one idea I'm kind of working through right now is depending upon within version has to be the very first line in the DSL, and then so it calls that function version within that base script class, and then I can check to see, hey, did they specify 0.1 or 0.2, and then change my binding based on that. Oops, I didn't mean to do that. VI mode. But change the binding object that I'm binding to, I can change that depending upon what they've specified. The other way that I'm looking at doing this is just basically when they specify a DSL script, that I just read that first line, right? And if it doesn't have this version tag there, this version number defined, then I just assume the latest version, right? And then I can create my rules, I call them rules. That's what I've been building. But in my binding, I can change up the object that's being bound to that, and that changes what functions you can call. So that's all I got. Any questions?
So were you able to finish your mule routing rule generator?
Repeat the question. Go ahead.
You have the microphone.
Oh, I got the microphone. Okay. Was I able to complete the mule routing DSL that I'm working on. I've got 4 releases out. I'm still working on it. I've got something I think is viable for people to actually use, but there's still a lot more that I want to do with it. One of the things that I'm finding that is restricting me is back to what makes Groovy great is what we've shown, but what makes it bad is that you're stuck in that realm. There's things that you can't do. So I want to have things more of a vernacular that we're used to speaking. I want to have those as far as some rule definitions, and I'm having to really kind of jump through hoops to define those functions and to define those name parameters, right, from a return from a map. And that's kind of tripping me up a little bit. So you are constrained, in the realm of Groovy. So that's kind of where I'm stuck at. I'm still working on it. Maybe in 6 months, maybe 3 months, depending on, whatever. But something like that, I might want to bring back, maybe show as maybe as a lightning talk. But it's what I'm working on is open source. So if you wanted to know what it looks like, it's just on GitHub. So. Thank you.